Presented with an arbitrary quadratic equation, it is not always easy to factorise it by hand, which we might want to do in order to find the solution. In such cases, we can appeal to the general formula, which works for any quadratic equation. Given the equation ax squared plus bx plus c equals 0, the values of x satisfying that equation are negative b plus or minus the square root of b squared negative 4 times a times c all over 2a. Remember that this plus or minus sign means that we will have two solutions, one where we will treat this as a plus and one where we will treat this as a minus. Let's look at that in two examples. In the first one, our quadratic is x squared minus 3x minus 2 is equal to 0. If we look at the general formula for a quadratic, ax squared plus bx plus c is equal to 0, we can see that we have a is equal to 1, b is equal to negative 3, and c is equal to negative 2. So, according to the formula, x is negative 3 plus or minus the square root of negative 3 squared, negative 4 times 1 times negative 2, all over 2 times 1, which is equal to 3 plus or minus the square root of 9 negative 8 all over 2, which is 3 plus or minus the square root of 17 over 2. So the solutions are x is equal to 3 plus the square root of 17 over 2, or x is equal to 3 minus the square root of 17 over 2. Let's look at a second example. Here we have 3x squared is equal to 5x minus 1. Now, this is not immediately in the standard form. By standard form, I mean the ax squared plus bx plus c is equal to 0 form. So, let's rearrange it into that form. We take the 5x and the minus 1 to the left hand side. Now, when we compare to the general form, ax squared plus bx plus c, we can see that here a is equal to 3, b is equal to negative 5, and c is equal to 1. So, if we substitute into our formula, we have x is equal to negative 5 plus or minus the square root of negative 5 squared, negative 4 times 3 times 1, all over 2 times 3, which is equal to 5 plus or minus the square root of 13 over 6. So x is 5 plus root 13 over 6, or x is equal to 5 minus root 13 over 6. It's important to remember that while this formula is useful, it can be slightly awkward to use algebraically, so it's best to try factorising by hand first, rather than immediately appealing to the formula.